Cool. This is what we're doing. We're going to wrap up this unit, wrap up this year with acids and bases. We'll have a quiz here on the 6th, another quiz on the 12th, our exam on the 14th, and of course your final exams. And then we will all be done. Okay, and we can get ready for summer school.
How many more tests do we have?
Right here's an exam and then final exam.
And then we just have finals.
Yeah, we got this exam, nice little, fun little exam.
So one definitely and possibly two for the people who don't exist.
Right. Okay. So we're going to be able to recognize, name, and write formulas for common acids and bases. The beautiful thing is, if you've been in my class, you already know how to do all this. Or you should, I should say. You should know how to do this. This is routine stuff we've been doing since October. Okay? How are they related in a solution? What are we talking about with hydrogen ions and hydroxide ions? Well, water self-ionizes, and what that means is water all by itself can break down. Water can break down into hydrogen ions and hydroxide ions. Basically, one of those little hydrogens pops off of the water, okay? And it does this to a very small extent. So we just went over molarity again. And what I mean by a very small extent is pure water has 1, 2, 3. That's the concentration of the hydrogen ions in pure water. Okay? So that's 1.0 times 10 to the minus 7th. Write this there. That's what we mean by a very small extent. Okay? Aqueous solutions, hydrogen ions, are always joined to water molecules. So this is the way we write it. But what's really going on sort of in the real world is this free proton, this free hydrogen ion, is hanging on to another water molecule and just being available. Now this second water molecule, this one here, is not really going to participate chemically. It's just that, y'all remember that oxygen has that -2 charge? And so this +1 hydrogen is going to just stick to it by nature until it comes across something to react with, in which case it will react with that. All right. So dissociation, aqueous solutions, hydronium ions. Because they join with water chemists, can refer to hydrogen ions as hydronium or protons. In this class, we're going to use either of those, and what we're talking about are these hydrogen ions in solution. We good? Okay.
We have the wrong package, right?
No, we don't.
I think he does. That's great.
Uh-huh.
Oh, well, mine's on the front page.
Okay. An acid is commonly defined as a compound that produces hydrogen ions when dissolved in water. And a base is a compound that produces hydroxide ions when dissolved in water. The Arrhenius definition is what you need to put in, is that an acid that contains hydrogen and dissociates in water to produce hydrogen ions. A base is a substance that contains hydroxide and dissociates in water to produce hydroxide ions. Good? All right. So this is the Arrhenius definition. It's a reasonable definition, and it's workable for us in this class. We're going to talk about another one in just a few minutes. So here's examples of that. So hydrochloric acid mixes with water, or hydrogen chloride gas, let me be specific, is bubbled through water and forms hydrogen ions plus the chloride ions. And that's sodium hydroxide breaks apart to sodium and hydroxide. You actually know how to do these. Acids start, the formulas start with hydrogen, as in these examples. As in these examples. So I've got, the first one would be called what?
HCl, or
So
hydrochloride.
hydrochloric acid.
Yeah.
And this one is,
Hydronitric,
no, this
nitrate acid.
nitric acid, right? And this one is
Sulfuric acid.
sulfuric acid. And this one is
Chloro-oxygen acid.
What's ClO3? Come on, man. We've been here all year long.
It's chlorine oxide.
No, it's not. What is that?
Chlorine and oxygen. That's chlorine oxide.
Okay, that's a polyatomic ion that you should know that I told you to memorize way back in September.
I got most of them down.
Okay, get this one down. What's this one? Right, it's an Audi. Chlorate. Ate too much, now I feel icky. Right, that's hydrochloric, that's chloric. Hydrochloric, hydro means there's only hydrogen plus something else, and chloric, that's chloric acid. Phosphorus acid, that's exactly right. This is phosphorus acid. Cool, y'all got this. As you become more sophisticated, some of y'all will, you're going to realize there's other acid formulas that don't start with hydrogen, and there's ways that we write things that don't start with hydrogen. We're really not going to jump in those on this class too much. Yep, and just, if you go to general chem or things like that later on. Let's recognize some bases. We'll recognize bases here. Okay. So the name of this first one is what? Potassium hydroxide. This one is. All right, cool. Okay, so the name of this first one is what? Potassium hydroxide. This one is nickel 1 hydroxide. This one is, yeah, y'all all got base naming. We can name bases all day long. I could give you a test on naming bases right now, and you could all get 100. You could. It's possible. Right? Later in our notes, we can learn that there are other examples of bases. I'm going to mention some, but I'm not going to stress y'all out on those. We'll hit those next year. Really, if you see it ends in OH, that's when you know it's a base. Let's look at those again. We just did those. I've got a metal and hydroxide. Boom, we're done. I don't know if y'all don't even have any blanks to fill in for that. I didn't think so. All right, this means we name and write formulas of bases the same way we learned to with ionic compounds way back in Unit 4. Way back in, you probably remember in October, I told y'all you're going to have to use this stuff for the rest of the year. Good? Okay. There are two classes of acids you need to know about. And again, this is review for you guys. Binary acids have how many elements? 2. Binary acids have 2 elements, hydrogen plus the other guy. Okay? Hydrogen plus something else. Oxyacids contain 3 or more elements. Specifically, they're going to contain oxygen. This is where the term oxy comes from. It's not just a good infomercial. Okay, got your binary acids, got your oxyacids. If you remember that binary acids, the formulas only have 2 elements. If I'm writing the name for a binary acid, it starts with hydro. Okay, they write the name of the second element with the suffix "ic," and then we add an acid to the end. This is the key here. We begin with hydro. That tells you it's binary. So this, the name of this would be what? Well, remember we got to do the ic, right? So hydrosilinic. This is hydrochloric. Let them in. So hydrosilinic and hydrochloric. What? No. All right. How about this one?
What's the walk run?
So HBr should be hydrobromic. This is hydrofluoric. This is hydronitric. Again, same stuff we've been doing since October. 2 exceptions. This is, if it was in phosphorus, we're going to use phosphoric, and sulfur, we're going to use sulfuric. So really we're adding, we're going to keep that R in there as the point here. So this would be hydrophosphoric, and this would be, yep, this is hydrosulfuric acid, yeah. So be sure and write that down. Good? Oxyacids, yep. It has to do with the flow of the name.
So it doesn't sound wrong?
Yeah, it doesn't sound weird. Oxyacids, this one has to do with 3 elements, specifically elements, polyatomics that contain oxygens. Okay? You start by writing the name of the polyatomic. The key here is you're not writing hydro. The key here is you're not writing the term hydro because hydro indicates it's binary. Good, we're still recording. So if the ending is 8, we're going to change it to ick. Like I ate too much and now I feel icky. Okay? So this is Well, what's this element here? What's this polyatomic called? Acetate. So instead of ATE, I'm going to change the ATE to IC. So this is acetic acid. So it's acetic. Yeah, like acetate, except ice. Okay. CO3 is carbonate, and I changed the ATE to IC, so this is carbonic acid. And again, you guys have been doing this for quite a while, so there shouldn't be a good? All right. If the ending is ITE, we're going to change it to OUS. If it's ITE, we're going to change it to OUS, and then add acid to the end. So an example, we say that bites are delicious. Okay. An example of this is ClO2 is chlorite. So we're going to change this to chlorous acid. How about NO2? NO2 is nitrous. We're going to change this to, or nitrite to nitrous acid. Yeah. Getting ahead of myself there. Good? All right, let's do some mixed practice here. HF, go ahead and do these. These should be in your notes. Knock those out real quick. First one is what? Hydrofluoric. This is dichromic. This is phosphoric. No. Phosphorus acid, right? Is that right? Phosphorus acid. This is hydrosolenic. This is sulfurous. This is, okay, you two in the back. Come on, help me out. Hydroiodic. Good? What was the second one? Dichromic acid. Because it's dichromate. Okay? So, and it's a polyatomic, right? Writing if the name has an acid in it and begins with hydro, you can conclude that it's a binary acid. So this is how to get the names from the formulas. Now we're going to get the formulas from the names. Okay? Hydronitric acid. Two elements here are so the hydro tells me it's going to be, because all acids are, but the hydro tells me that it's just hydrogen plus nitric is going to be nitrogen. So the two elements are hydrogen and nitrogen. Hydronitric. Good enough. From here we follow the same 4 steps we used in ionic compounds. I'm going to write the H, and the charge of that's going to be what? +1 over here. And nitric is N -3. We're going to crisscross that. We're going to get what? H3N. This is the same thing. You still are going to have to do the crisscross. We have to crisscross. Some people just want to write the letters straight down. No, you're going to follow the same steps we've been doing since October. You're going to write the crisscross. And that's all I did there. You're going to write the subscripts. You're going to crisscross them. You're going to reduce. If you need to, we're not going to erase because we're not going to do that. We're either going to rewrite it or just do it right the first time. Hydrochloric should be what? So hydro, I know is going to be binary, so I'm just going to put an H here and a plus, Cl, minus crisscross, it is HCl. All right, oxyacids. If the name has acid in it and does not begin with hydro, you must assume it's an oxyacid. It's one of our polyatomics. It's one of our polyatomics. It will still begin with a high H, but then it's going to be followed up with a polyatomic. Oops. Okay. Good? So perchloric acid, the two parts of perchloric acid are, what's one part always if it's an acid? Hydrogen. It's going to be an H plus here. Okay? Now let's work backwards. The ic is going to be what? 8. And so perchlorate, the formula for perchlorate is ClO4. ClO4 minus 1. Good shape. All right. What's that give us? I crisscross those two things. So it's HClO4, perchloric acid. Just like that. This is all the pretty stuff that I just drew up there. We good? All right. Phosphorus acid, OUS. OUS, let's remember OUS is going to be ITE, and so that's phosphite. And so the two parts of that is going to be hydrogen always, and phosphite, which is, and the charge on phosphite is What is it? -3, the same as phosphorus. If you don't have your polyatomics memorized, oh my goodness. This is something that should have happened way back in October. I'm going to crisscross that, and I'm going to get what? H3PO3. That is phosphorus acid. Phosphorus acid. I think there's some pretty slides here to make up for that. Okay. Bites are delicious. Okay, we did the crisscross. We made our little pretty formula there. You guys go ahead and try hydrofluoric. That is misspelled. Sulfurous and hydrosulfuric. Did you get all done? Almost. Almost. All right. Hydrofluoric. You got these written down? You got them all? You good? You got them all written down? Getting there, getting there. Hydrofluoric is going to be what kind of acid? Binary. That means it's only going to have what two elements? What two elements are those? Hydrogen and fluorine. And fluorine has a charge of -1, so we crisscross, and hydrofluoric is what? HF. Sulfurous is what kind of acid? It's an oxy. It's an oxy acid, right? And all acids are going to start with what? H. So I'm just going to put an H here with a little plus sign. And sulfurous, that's going to be what? So this is sulfite. And sulfite's formula is SO3 minus 2, right? And I crisscross that, and I get hydrosulfuric acid. Now, hydrosulfuric means it's going to be what kind of acid? Binary. So I've got two things. I've got H plus, and sulfuric is going to be sulfur, and its charge is, crisscross that, I get H2S. Good? All right. Hydrosulfuric. Is that an acid, a base, or a salt? Acid. Y'all have that chart in your page here? Let me go over that. That's going to be an acid, and how do I know it's an acid? It says so. The cation for this is going to be what? Hydrogen. For all acids, that's going to be the cation, and the anion for this is going to be what? Okay, and so the formula is H2S. I'm going to take a few seconds and y'all can fill that out. So that's a good question. So let's look here. So sodium sulfide. I don't have a hydrogen ion and I don't have a hydroxide ion. So ammonium hydroxide, let's look at this one. Ammonium hydroxide, the cation is ammonium. The anion is hydroxide. And if it's got hydroxide, that's going to be a base. If it doesn't have either, okay, Okay. It should be day 1, right? Yep. So y'all should be able to finish this as a part of day 1. All right, sounds good.